This is demonstrated in many ways, but I will show in a little bit of detail 2 projects we've been doing for New York. But first, a little bit of background, because there's an aspect to this work which is actually very old. And this has to do with what we call cognition. Cognition is really how the mind processes feelings, senses. It's basically how, in our case, we sense the city. And of course, social media is very much about sensing. And now we're in a very different moment for this exact reason, that we have new tools. So we've been looking at Twitter, of course, and we've also been looking at apps for a new generation of infrastructure in New York City. So I show this very briefly. Then we can have questions, or you can interrupt. I don't, it's fine for me. You can ask questions. But there's nothing really new. I mean, this is from France in 19th century, I think 1839. I'm not so good, 36. This is Fourier's Valence theory, and in this case, the argument is that new social form in new physical form will influence human behavior. So there's a connection between behavior and spatial form and social form, and this comes from an earlier generation of work by Fourier. This is actually a project based on Fourier's ideas, and I won't go into this in detail because I think we don't have time. But just to say that we're in a tradition, but now a very new moment. This is the Piranesi, famous Piranesi Campomarzio plan for Rome. This is what, 1762, in which the historical fragments of Rome are related in new ways. And this has to do with criteria which are hard to define today, but they have to do with formal criteria, but also social criteria. How did the old parts of the city, in their stage of basically, they're basically ruins, but how do they get reconnected now in a new way around social ideas? This is also the Noli plan of Rome, which is very famous. 1736 he began, and here he's playing with the idea of urban space, interior and exterior, and how these two realms, which are normally separated, are interconnected. So you have interior, exterior, and how they're related to each other. This, of course, now is much more recent. 20th century, this is Kevin Lynch's cognitive mapping for Boston, the image of the city, in which he's trying to map the city in movement, and how it's perceived, not statically, like in a static map, but how it's perceived as you move through it. These are all ways to understand the city in non-traditional static terms, but in terms of experience, let's say. This is the Situationists in Paris in the 1960s, in which similarly they're looking at how to map the city as a dynamic social organism by moving through it. And this is actually related to earlier work by Flaubert and the dérive in France, the dérive being a method of moving through the city and describing it in kind of very behavioral terms, let's say. In this case, this is the first digital design model. This is 1960. This is from Community and Privacy by Chermayeff and Alexander. Alexander goes on, of course, to make several famous texts and work. Notes on the synthesis of form is one. In this case, We have behavioral constraints being correlated with each other and eventually with spatial pattern. So instead of just having a static notion of function and form, now we have a dynamic model. And of course, this is really pioneering work because it's 70 years ago now. The computer which produced this work was probably the size of this building, you know, at MIT. And now, of course, you can easily do such things with your laptop or maybe even your smartphone at this point. So I don't mention this in any detail, but you know, it's very interesting, I think, to say a background of some sort. This is pioneering work that I did in 1969 and 1970 in Philadelphia, a very, very degraded ghetto, the worst of the East Coast of North America. And I won't go into that detail, but we were involved with mapping the social characteristics, digitizing them, and then making a dynamic model of how changes could occur one from another from another. If this is of interest, I think you can still download it on the internet. It was a very large study. But this is before computers. We did this by hand. We did many maps simulating, you know, did point by point the thing. But we understood this was going to happen. So it took about 20 years with the PC in 1990 or so, and with the Esri platforms that came out, GIS, before this could happen. But it hasn't been done, which is very important. So I studied information theory and cities before there were this kind of computing capacity, but there was very interesting theory that came out of World War II, out of radar and these early systems. And there were very famous texts like Ross Ashby's Design for a Brain, which tried to begin to understand how the brain as a cognitive instrument functions. And of course, I was very interested in how this eventually might happen in real time in cities, and it took a while. But I'm very curious, I'm very interested now that after a long period of not using this work, I start to understand now how we can actually use it, because the technology is catching up with the theory and the ideas. This is from Philadelphia. I won't go into this in detail, but there were ways to correlate various layers, which now we can do in GIS, of course, easily, and to produce simulations of change. These were the algorithms which were used and the interactive software, which was, of course, simulated but not possible at that time. So I won't go into this in more detail, but I've continued with the classes that I teach, and I think it's very important. This series, these are only a few series, I think we've studied probably 200 cities, in which we use the old technique of the figure ground and transform it using spatial algorithms as class work. And we've done some very interesting studies for Seoul with Korean students who've been come and gone. But this is a very important. This is where GIS starts, Esri, 1969, and of course it evolves to now, within the last 10 years, I mean probably every city in the world of some resources, and this includes of course Africa, has GIS platforms which begin to build a database for the cities. At the same time, this is from the work we've been doing with Twitter. This is Twitter density, and I'll come back to this in a few minutes. But we can begin to geospatially map Twitter messages in the Esri platforms. So we have basically a fundamentally new layer of data, which is not just land use, not just where the houses are, but now it has to do with what people are thinking, basically. So I'm making a very simple explanation, but that's basically what it is. How are people processing their environment? Okay, so first of all, we backtrack a little bit around the social media side. This is an interesting experiment that we did at Columbia in a dormitory. I won't explain it in detail, but there were two groups. One group had a social media platform that they could all access. The other group didn't. And that social media platform measured how much energy they were using. The other group didn't know. And of course, predictably, I don't know, well, you can't read this, but anyway, this is the group that knew, and their energy was reduced by 20%. Because of course there was a kind of competition set up, or a knowledge base that meant that they understood they should reduce their energy use. So this starts to be very important in the whole energy equation, right? How do we, I mean, we're at the point now where we have to devise more ways of reducing energy consumption than just having a better wall or you know, a more efficient system. We also have to get into social media and awareness to understand how to do these reductions, and the reductions are very important, of course. But this one, this is what I'd like to talk about in a little more detail. This has to do with the app that we developed for New York City, and then we'll go into the Twitter work, and then we can talk about it. This app has to do with a next generation of infrastructure for New York. New York is old, relatively. At least we're old as technology. I mean, we have technology that was modern 150 years ago, but not today. And one of the key problems of New York has to do with stormwater and wastewater. Because if it rains a tiny amount in New York, just like this, we have, of course, that rainwater going into the sewage system, and the sewage plants can't handle it, so it gets diverted into the rivers through here. So we have all these points, some big ones and smaller ones, where when it rains, the sewage goes into the rivers. Because we have one pipe. We don't have two pipes. If we had two pipes, the rainwater would go into the river without getting mixed up in the sewage. I'm sure Seoul must have two pipes, right? At least the new parts of Seoul, it's all modern. Anyway, New York will never have two pipes. It's impossible. I mean, the cost of that would be incredibly difficult. So the city has begun to implement a program whereby the stormwater is caught before it gets into the pipe. In other words, on the street. And it's diverted into what we call bioswales, which are small green areas which absorb the water directly into the ground, rather than taking it into the pipes and into the river. So the stormwater is now diverted in this way, which is something very new. It's basically called distributed infrastructure, and this involves thousands and thousands of these small points. And well, this is the area that we studied, but I'll come back to that. These are all the CSO areas where the sewage would go in. These are the points that we studied. But here you see what these diversion, they're little tiny gardens basically that absorb the water. This is our study site, and I'll go very quickly, but the question is, for this, how do you maintain this? This is like thousands of tiny little gardens. So the question of maintenance is extremely important, and in our argument can't be done without social media. And it can't be done without community participation in this process. In other words, the city cannot have an enormous bureaucracy for thousands of these swales, you know, and make any sense of it. It's not possible. So it's a new concept of infrastructure, a new concept of maintenance of the infrastructure, but also a new concept of monitoring, because this data will go into a back-end base which also records how the actual vegetation functions. So that's it in a nutshell. And in this case, we developed this app which has gone through several stages. These slides are a bit early, but with this, you can, at the swale, record what's going on, and it gets sent to a central database. And here it is. This is our study site, and these are all the points that were to be measured. This is how the stormwater works. It gets intercepted into the green points. This is, of course, the street section, how it works on each side. Here is one. It's even interesting how much water goes in and then how much absorption there is, and how much leaves, of course, because you have an entrance and an exit. How could you measure this without, you know, this thing? It's impossible. And this work is developed over now 3 or 4 years and become very interesting. These are the sites. Here are the two ways that have been used. This is individuals just coming down the street and seeing something. This is more activist groups. But we've identified, and I don't have slides of it, that probably the most important group is high school students, who of course know much more about this than we do. And with the high school students, you can have access to the families and community much more easily. So there's a generational thing that's also part of this infrastructure all of a sudden. And of course, we've been working, we haven't started yet, with the next generation with high school students, in which they would also actually improve the app itself. And this is considered very important. We understood that it's important to understand the communities themselves. I mean, who are these people? And in New York, they're very diverse communities. So one community might function with the new infrastructure in a different way than another, especially in terms of being a community, who they are, the demographics and all that. And from that, we got interested in how we might use new social media data to understand the communities. And that got us into the Twitter work. Why Twitter? Because with Twitter, do you have Twitter here? You must, right? Use Twitter. Yeah. I mean, there's a little button you can push, and 10% of Twitter users say it's okay to use their data, something like 10 or 11%. So that gets us around the privacy problem, which the university is very strict about for sure, and so is everybody else. So we have millions and millions, billions of messages just from the 10%. And those messages are located geospatially. So if I'm standing here and I send a Twitter message and I say it's okay, look at that message and use it, it's automatically mapped. Well, not automatically, but it is. And that mapping can be correlated with GIS mapping. So this is where we got very interested in the question of Twitter, and then we got interested in the question of sentiment. Because with the Twitter messages, with very sophisticated algorithms, you can understand what people are thinking about, or whether they're happy or sad or, you know, whatever, hungry, I don't know, whatever they are, right? And there is IBM software which has been developed, but at Columbia there's what's called the Data Science Institute, and they've developed proprietary software which is very advanced. So we began to work with those folks, and we had some graduate students working with us as part of their thesis work, and that's how we got to this point. This will we'll come to this. This is the density of tweets and the subject. And here's basically the process that we've gone through, and began to look at the question of public space, and then at 3 parks. I'll go very briefly through this. But this is important because you can tell many things, you know, relatively easy. This tells us these are the Twitter areas. But we have much more fine-grained data than this, but these are the percentage of residents and tourists tweeting from these areas. These are the actual tweets. So this is really a new field. I mean, in the next 10 or 15 years, really, there will be a next generation of urban infrastructure that's going to be very important. Also dangerous, so we can discuss the flip side of this, but it's there. And so sometimes, you know, last spring I gave a lecture in Belgium about this, and people got, you know, and they were architects, they got very excited and thought, but this is terrible. How can you possibly look at these things? And of course the answer is very simple, because if we don't understand it, we're outside and it's happening. But anyway, here are the parks. Here are the 3 parks, the High Line, Bryant Park, and Washington Square, and we focused on these. We thought to go out here, but the tweet density is too low. So we start to focus on the southern part of Manhattan, which is here, where we had really a very good density. Here are the parks. They're quite different. This is the New York Public Library, very dense commercial area. This is the High Line, which you may know is the converted rail line that, you know, became very much used. And Washington Square Park is an old English square, but now very much used by students and many others, a little more residential. We move from raw data. This is just all the words, then the words get, and this is a quick overview, the words get organized into what are called clouds, and the clouds start to identify subject matter, and you can move cloud to cloud. And then the metadata locates from the word cloud you can go into specifics, let's just say. So we go from data collection, processing from the raw data, and then the natural language processing is very important. This is where we get into sentiment, what we call sentiment, which is, you could just say happiness and not happiness, but it can be many things, of course. And then there's the statistical analyses related to, in this case, to the 2 of the parks, and the visualization. Again, here this is natural language. Our ultimate goal was to produce planning tools. And when you think about how important this is, we won't go here. This is a little bit. We can now understand the use of space. Let's take a park or just an urban space in terms that you couldn't possibly do historically. I mean, we can have a point and we can know what's been said about it or what's the sensibility of that point is for the first time in history. And until now, how did you know this? These kind of data? Well, you went there, you know, you had a clicker, you did an interview, you know, and maybe you could do 100 or 200, and what good was it? Well, the social science folks were happy because it kept them busy. But now in real time we can know this. We can know how people are moving through that space in real time, which is huge. But we're just at the beginning of this new technology. So this is night and day, and the topics that we started to focus on. So this is coming out of the word clouds. These are activities, you know, events, food, vegetation, weather, of course. Here's Bryant Park. Here are the densities, the topic, and sentiment. This is now 3 years old. Within 2 more years, we'll be able to have a much more fine-grained recording of this. But we still do know where the points are. And so our thought was, well, why can't this become a design tool? So if the park is to be redesigned somehow, why can't this be one of the determinants? You understand whether, you know, something should be over there, how the vegetation works, how the, you know, the benches work, how anything works, right? And so that's that's the goal. These are geolocated tweets in density. Now this is already obsolete. This is from 2.5 years ago, I think. Now you're going to get much more fine-grained than this. Here we have again the parks. I won't go into this, but this is very interesting. This is very basic, but here we have in real time the density of tweets and the subjects. And so we could start to see, well, on this day there was a film festival. On this day there's some, I don't know what this stuff is, a yoga class, right? And this can be predictive, which is very important for the High Line. We'll come to that in a minute. Here's Washington Square. We'll go through the same thing, so I won't go through it in any detail. We have, of course, to translate this granularity into the actual spatial characteristics. This is still primitive, but this is changing fast. I mean, 3 years ago, the radius of geolocation was probably from there to here. Now it's this, right? And so forth. Yes, this was Black Lives Matter, tango lessons. When Bernie Sanders showed up, which is just off over here, there probably, I don't know, there's 800,000 people, 1 million people. But we caught it, of course, because we're continually downloading the data, but we didn't map it that far. And here's, of course, the High Line, which is a much larger area. And in this case, it's elevated, so there are questions about geolocating in elevation and on the ground. But I won't go into detail. But here's the High Line, of course, down here. It gets converted from a rail line to now a very, very fancy neighborhood. It goes from working class to very wealthy people, and it's a particular interest to understand the social data relative to that question, but also relative to the use of the High Line, because there have been several times when it has had to be evacuated because there are too many people, and that could have been predicted using the Twitter feed, because you can tell maybe 2 or 3 hours ahead of time the interest in how, you know, how it's going to be used. So it's even, you know, potentially interesting for prediction. I won't go into detail. These are the various areas and the topics. But we move from this. Here's the High Line, which has very high spikes. That's a big problem for them. We worked with the managers of the High Line. Here it was, of course. This is my favorite moment in the High Line. And of course, a studio we did in 2000, in 2001, yeah, with Moji Baratlu, in which we saw the High Line as an information transect through the city. But of course, there wasn't the software for that yet. Now there is. So they're very interested in some kind of installation of an information system. So it's not just walking through grass and trees and flowers, but it's walking through a kind of information highway. We don't know how to do that yet, but that's a good one. I think that's an interesting one to pursue further. Anyway, then we start to say, well, okay, it's not quite time for the design details for as a design tool using Twitter, but we can look at other things. So this is the last project, and this has to do with trying to understand for parks how they interact with people. In other words, the question of sentiment. Is it true, like historically, parks are seen as good, right? I mean, everybody says, yeah, we got to have more parks, and we got to, you know, all this has to be, you know, historically, since the industrial period, green was seen as an antidote to the industry and something automatically good in public space and all that. So we said, well, with Twitter, let's see how this works. If it really works out, you know, because we have the sentiment tool, right? So we started with parks in all of New York City, and then this is a Twitter density map, and we got, of course, focused especially on the southern part of Manhattan, where again, there's enough density that it can really do something. And from there, we started to figure out the density clouds here, contours, and we're looking, of course, at messages. These, you can actually see the message, and then you can run the software to try to understand it. So these are actual messages with the sentiment labeling, which has to do with how the software processes it here. And yeah, well, this is an interesting thing in itself, because here we're looking at how the density interacts with the old infrastructure. But beyond that, for New York, what's really critical is within probably only several years, the subway system will have continuous Wi-Fi in the cars. So we're actually going to have a moving database for sentiment within all these subway lines. So now they're off limits because they're underground, they can't transmit, right? So we're, again, for the infrastructure, this is an enormous change because this is a tracking system for people's thinking, right? And here we have the results of that work, the overall work for the city, and then for this is sentiment for all of New York City, and this is in park and outside the park, and of course, predictably for most of the city, the sentiment was more positive inside a park than outside, but it wasn't true for Manhattan. So we took a long time to figure that one out. And we thought at first that the modeling was incorrect. There was something wrong. And we were very worried about that because we spent some money to figure this out. Yeah, here you see in park, outside park, overall. I won't go into this, but it's important to understand that the notion that parks were positive wasn't always going to be true, depending on the urban context here, this is clearer. Yeah, these are in park in Manhattan is lower. And here we see the mapping of that sentiment in the parks, but we won't go into it. This is clearer. We start to see the parks and where, because we start to look and see, well, what's wrong here? Why is this not more positive? And we go through all these analyses, and finally there was the eureka moment, because 2.5 million people come into Manhattan every day for work who do not live there. So their use of a park would be very different. In fact, maybe they go to the park to complain about their work, right? So this is the stage at which this work is at. I mean, if you're interested in the algorithms and things, we just published something and you can find it on the website. But it gets to a very interesting moment where we see the precision with which we can begin to understand how public space works. Starting with just this general question of what's wrong with this model. The model was actually okay, we just didn't know what was going on. Here's the commuting map. This is day and night. These are all commuters. Traffic. That doesn't mean they don't go in a park. Maybe they go in Bryant Park and eat a sandwich. But they're there for a very different reason than somebody out here during the day that's taking care of their kids, or at night are going there just to relax. So anyway, this is this thing. If you're interested, you can take a look at it. Send us an email.